Well, there's two types of sexual systems. There's a reflexive one, which looks at autonomic activation, genital reflexes and sensations, innate copulatory behaviors. These are the kind of things that we typically study in animals. And we don't think animals learn anything because they don't need to because they're animals. We're different, right? Well, no. What happens is we tend to study the incentive systems, okay? The kind of things that Porfirio was talking about. Pavlovian associations between sexual stimuli and the rewards or punishments that you get by going after them. Operant associations between sexual behavior and reward and punishment. So what you do, how well what you do works. And maybe you'll learn something new and you go, oh, that worked even better, okay? So you learn this as part of your whole lifespan. What you think now isn't what you're going to think 10 years from now, because things will change. It's like, oh, a new lover changed me completely, yeah? So, and when we look at this, we typically use erotic stimuli, visual stimuli, porn, to look at it in a magnet. And what do we see activated? Well, you can see the hypothalamus activated. You can't really see the regions activated, which you can in rats. But when we look with fMRI, we see these limbic structures and cortical structures that get activated. Do we look at those in rats? No, because nobody does, because why would you? Because they're just rats. They don't think, or do they? This thing is going to kill me. How is it that other people worked it and it just, okay. Actually, why don't I just ask you to, yeah. So one of the things that's clear is that learning is a critical feature of imprinting. And this is true of Konrad Lorenz and the Goslings. It's also true of sheep and goats. And it's also true of people. We learn what context, partner features, sexual stimuli, behaviors arouse us. We learn what context features and stimuli behaviors produce sexual pleasure. The big elephant in the room, sexual pleasure. What you like about it, what feels good about it. We also learn what we don't like and what not to do, eventually. So for some of us, it takes longer. But it involves an interplay between Pavlovian, meaning stimulus-stimulus associations, and operant, response reinforcer contingencies. All those boring things you learned about in learning class as an undergraduate. Well, this is where it hits the real world. So something has to integrate the pathways for attention and reward, that mesolimbic dopamine system, with arousal and bonding. All these hypothalamic systems that involve oxytocin and vasopressin, and in rats at least, who live in an olfactory world, are responded to because they're odor cues that signal them. Well, what might that be? A connection. Go back, please. This connection from the preoptic area to the ventral tegmental area. It is the connection that connects those two systems together. And it's a connection that strengthens with experience, with sexual experience. That's why sexual experience, like any experience, is so important for you to become a master of it. Well, what's rewarding to a rat, and how would we ever know sexually? Pleasure, plaisir. Conditioned place and partner preferences are induced by the pleasurable state after ejaculation in male rats, when we think they're asleep. They're induced in female rats by paced copulation, meaning copulation that she controls, and by manual clitoral stimulation that we distribute in a way that mimics the preferred rate of her copulatory stimulation, because that's what she's getting out of copulation. Oh, who would have thought that? Okay? Moreover, both females and males emit calls that signify an appetitive state, so high calls in the 50 to 60 kilohertz range, that form trills and flats, and low calls in the 22 to 25 range after ejaculation or after an orgasm-like response. So we can hear them say it, and we can watch the behavior that's associated with that. Next. Oh, he's gone. Okay. Sexually conditioned place preference, CPP, and sexually conditioned ejaculatory preference, CEP. How do we know this exists? Well, we've studied it. Here's a place preference box. Rats typically like to go in here. So if you bait this side with something good and this side with nothing, and then you put them in here, after a while, they're going to go here and stay there because they like the place that's associated with something good. Likewise, we can test their partner preference by giving them free access. Here's a male, and with two females. This is called an FFM test, 2 females, 1 male. If one female is different from the other, and he prefers that female, he's going to go after that female. Same thing with an MMF test. The female will go after one male that she prefers, or she'll do them both. It just depends. We know that the state induced by ejaculation is necessary for conditioning. I'll show you that in a second. We get stronger conditioning when males are more aroused prior to ejaculation, so it's not just easy, but they have to wait for it. Oh, Stendhal was right. The acquisition of either is blocked by the opioid receptor antagonist naloxone. Okay, that's a drug that binds to opioid receptors and blocks your natural opioids, which are released during orgasm, from binding and producing a pleasurable state. It's not blocked by dopamine antagonists. So how do we know this? So Todd Kippen in my lab did this study a long time ago, where he had what we call receptive paired trained males, where we had an almond odor on the female. Now, almond, lemon, these are neutral odors to rats. They don't prefer them. Something like cadaverine, they get disgusted by. They don't want to go near it. It's the smell of death. And something like vanilla, they love. Okay, so you don't want to give them something they love or something they hate. You want to give them something that is neutral so that you can see conditioning. So in this case, they get receptive females scented with almond and unreceptive or non-receptive females who beat them up with no odor. So the odor means yes, no odor means no. And guess what? Male rats actually learn that no means no, which is really funny. They should teach us a few things. Then the non-receptive paired males get the opposite order. Almond means no, but no odor means yes. Okay? And then this random paired group sometimes has the odor when they're receptive and sometimes has the odor when they're not receptive. So the odor means nothing, and nothing means nothing. So what would you predict? If we gave them an FFM test with an unscented receptive and a scented receptive, who are they going to go with? Yeah? Well, there's the question, right? So what did Todd find? Here was the training. We did it in bilevel chambers, so the odor was put in the back of the neck of the female and around her anogenital area. So here she is making a solicitation, a headwise orientation, hops over the male so he can sniff and lick her anogenital area. She kicks him in the face and runs away. He chases. Then she holds a lordosis so he can mount and intromit. And this will repeat until he finally ejaculates. We give them 9 trials like this, and then we put them in this open field with 2 females. And we just say, free access, who do you do? And the females compete with one another, right? So if the male actually shows a preference, he's got to work against their competition, which is really interesting. So what do we find? Well, here's the choice for first ejaculation and the mean number of ejaculations. And you'll see that in the random paired, they're 50-50. They go with whoever's in front of them. But the other 2 show a clear preference for the females that were associated with their ejaculation. Okay, the ones who said no, in this case these ones, well, they didn't ejaculate first or much with them. They ejaculated more with the scented female. These ones ejaculated more with the unscented female, first and more. And, in fact, they're also showing more mounts and intromissions with that female, too. And it's a weird thing to see because they're both these females are receptive. Okay, so they're going up to the male, Jorge's going to be the male, I'm going to be the hembra, and they're like, oh, do me, baby. Yeah, you're going to do me? Ugh. And they're running away. And it's crazy because the male will be like, yeah, not you. You beat me up. I'm going after the other one. Right? So that's what you see here. Phenomenal learning in an animal that has a thin little brain, or so we think. Then Todd asked, well, what's the component that produces the conditioning? What's necessary for it? So they either had 5 intromissions before ejaculation, an ejaculation and the female was pulled out, so they couldn't spend time with her in that post-ejaculatory period, or time with her in the post-ejaculatory interval, or 2 ejaculations, which assume that this has happened. And lo and behold, the conditioning occurs when he can be with her in the aftermath, or what we call in English, the delicious afterglow. Okay? That period where they just kind of stay together. And okay, well, what is that then? This is post-orgasmic learning. This is what Stendhal called the second crystallization. This is a period where this is occurring. If he ejaculates and she's not there anymore, so you've you swiped left, and then you hooked up, and then you left. no learning. Okay? Learning requires time. It requires protein synthesis. So what about female rats? Do they show the same thing? And these were studies done by Dr. Genero, or pre-Dr. Genero, El Nino, as you can see here. When Genero came to my lab, El Nino, he looks so cute there, doesn't he? Like, this is cuteness. Okay, he actually looks like his son, which is amazing. So what did Genero find? He did the same thing, but in this case, gave the females paced copulation in these chambers where there are holes that divide her side from the male side. The holes are too small for the male to get through, but they're just right for the female to get through. So she can run back and forth whenever she wants to get what she wants from him. And he either has an odor or no odor. No odor would be without this, which means it's kind of at his discretion. With the barrier, it's at her discretion. And guess what? She likes that. Who'd have thought females like to control? Yeah? Which is a good thing. Remember that. So we do partner preference and place preference. The ability to pace the initiation rate of copulation, so to control it, was necessary for conditioning. It induces an orgasm-like response. Timed clitoral stimulation was also capable of inducing that, which I'll show you in a minute. And just like the males, the acquisition was blocked by naloxone, but not blocked by a dopamine receptor antagonist. The acquisition. So they need to experience the reward to be able to show the conditioning. Yeah? From Genero's data, these are what solicitations look like, what lordosis looks like, and there are different degrees of it. Well, in the paired group, first solicitation latency was lowest for the scented male. They had first solicitation was given to the scented male. They had more solicitations on the scented than the unscented male. They also took the scented male's first ejaculation. Now this is interesting because the males are just ejaculating. They're showing a mate choice. I choose to deliver my sperm to you. The females are saying, I choose you to deliver your sperm to me. That's a bit more powerful, isn't it? Because it's a partner preference and a mate choice. Yeah? And they also showed way more lordosis magnitude 3s with their preferred male. Okay, so they're more aroused. They show better sexual behavior. Well, yeah, it's your preferred male. It's not some random person on the street that you've never met before, or in Genero's case, that you have, but you don't particularly like because you don't get the sex you like from that individual. So we also looked after 2 reconditioning trials. We presented the odor on gauze because you can. We did this in males as well. The odor itself now has acquired conditional value as a reward and as something that would stimulate arousal just on its own, even though it was neutral. You can see that here. Look at the piriform cortex, this main olfactory cortex, medial preoptic area. Wait, this is the ventral tegmental area, and you probably can't really see it, but in the middle there, you've got a bunch of activation on the sides, but in the middle, right, this is odor paired. You see it activated here. Here you see it's silent. And that's where dopamine neurons reside of that mesolimbic system. So it's silent when they're presented with a perfectly good macho, okay, but not their preferred macho. Then we get their preferred macho, well, now you've got all this activation of mesolimbic dopamine, and notice you also have preoptic area activated. And you can see it here, when they're presented with the odor alone, you have way more activation of that whole pathway, both of those pathways that I talked about. Yeah? Now, that's a female rat clitoris. It's a pretty big clitoris, and it looks just like ours. Okay? Speaking as a woman now. Here's her vagina, here's her anus. Here's what it looks like. You can see the glands, you can see the crus and the vestibule. And when we do clitoral stimulation, we use a paintbrush, a very soft, fine camel hair number 4 paintbrush. If you ever want to stimulate a rat's clitoris, use a number 4 camel hair paintbrush. Why is that so good? Because they love it. And we did it either when they were with masks, so they got one every second for 5 minutes, which is not kind of under their control, or distributed, okay? One every 5 seconds for 5 minutes. And we repeated this, right? Now the question is, do they like it? They come back for it. They wiggle their ears. They do exactly what I did to poor Jorge, right? Presenting themselves, saying, okay, you got your magic wand. Give it to me now. But do they really like it? Well, it turns out that, yes, they do. They show conditioned place preference. So there's a preference now to be in the dark side and away from the light side. They show a preference, and it activates regions of the brain that are part of those two systems. Yeah, well, that's kind of cool. And you can see that activation, this is the medial amygdala. You can see that activation with both the 1 and the 5, but you see the MPOA activation with the 5, okay, where it's distributed in time, which is kind of what they're doing by running back and forth. Okay, they run away from the male, they go back to the male. When do they go back to the male? About every 5 or 10 seconds. Yeah? So we give them what they want, they like it. We then did it, remember, these females are sexually naive. Yeah? They've never had sex with a male before. So here, oops, no, can you go back? Sorry. Yep. So here you have the odor on a gauze pad while we're delivering the clitoral stimulation. So it's not even on a male, it's just on a cotton gauze pad that's there. In this case, right, they get clitoral stimulation, or what we call CLS, unscented, and no CLS scented. Now, how do we do no CLS? It's easy. You raise the tail, and then you don't touch the clitoris. Okay? Female rats don't particularly like that. Scented, they get CLS with the almond on gauze, and then no CLS with water. And we give them repeated pairings of both of these, and then an open field test with 2 males, right, like you saw with Genaro. Well, look at this, CLS unscented, they solicit the unscented male more than the scented. CLS scented, they solicit the scented male more than the unscented. That goes also for hops and darts, which is another form of solicitation, and for their first solicitation, and for the time spent with the male. Now, why is that so intriguing? This is their first time with a male. They've never had a male. It's like being, I don't know, young and masturbating before you've ever had sex. What do you think about when you're doing that? Who do you think about when you're doing that? What are those features that you're kind of beginning to congeal in your own brain to develop a type that you're attracted to, right? And where do you find them? Okay, so that's intriguing. So essentially what it means is, el placer crea deseo y preferencia. It creates desire and preference. Pleasure does that. Now that's true for food, and we would never even give that a second thought. But for sex, it's like, what? That's crazy, because it should be innate, but it isn't. But how? And this is what I want to really get into today. How does this work? Well, rule number 1 is the primacy of first experiences with pleasure. Okay? You may not remember the first time you tasted chocolate, but you will never forget the taste of chocolate. Even if you have horrible Alzheimer's, you will never forget that chocolate is chocolate and that it's pleasurable. Okay? So, does this ring true with sex? And sure enough, it does. Gonzalo Quintana in my lab looked at something what's called UCS pre-exposure and CS pre-exposure. And in Pavlovian conditioning studies, these are done routinely to make sure that the first thing that happens is going to be the biggest thing that happens. So what did he do here? Well, UCS pre-exposure would mean that they either got 1 exposure or 5 exposures to an unscented female who they could copulate with. So they copulated with her once to 1 ejaculation or 5 times to 5 ejaculations. Then they got 9 conditioning trials with scented females. And then we gave them the open field choice test. Now what should happen if the first experiences matter, yeah? Then that first experience should wipe out the possibility of conditioning to the odor, because now you know how it works. And the unscented one is the first one. Well, sure enough, the unscented one, there's no conditioning, whether they got 1 or 5. So 9 conditioning trials, right, were not able to offset that first experience. That's pretty interesting. UCS or CS pre-exposure is the same thing, but now you put a gauze pad in with the odor. Okay, so like we did before with the sexually naive females. Put a gauze pad in 1 time, 5 times. Okay? What you're learning by this is that the odor means nothing. So when you pair it then on a female, it should mean nothing, because it meant nothing the first time you were exposed to it. It's also called latent inhibition, right? Because it takes more trials to produce an effect. And sure enough, that's what happened here, right? One trial, and then whether they got scented or unscented afterwards, one trial was enough to completely, one trial was enough not to abolish the conditioning, but 5 trials did. Everybody clear on this, right? You're essentially making the odor mean nothing, right? So here's the odor. Oh, I smell the odor. That's novel. What does it mean? Nothing. Nothing bad happened. Nothing good happened. Now I'm going to try to condition that odor. With 1 trial, you still get conditioning, but with 5 trials, you don't. Okay? So what it means, again, is the first experiences matter, and the UCS is stronger than the CS. Everybody with me on this? Okay, good. Here's another one, somatosensory conditioning. When Genaro did his studies, he had to tether the males. So one male would be scented, the other would be unscented, right? Now tethering, why would he tether them? Because the male rats are very cooperative, right? So it's like, you know, here's me and Jorge. It's like, please, after you. No, please, after you. And then we would crawl all over each other. And if he's scented, now all of a sudden I'm scented. Sorry, you're my, yeah. Anyway, so they would crawl all over each other so that one, you know, the unscented male would now be scented, right? I don't know if you ever had this experience in an elevator. Somebody's wearing way too much perfume, and you spend the rest of the day going, oh, God, I've got that guy's perfume on me. Okay, so we had to tether them. Genaro went back to Jalapa. Somebody needed his males. They wouldn't copulate. And they were great copulators. So we thought, okay, let's put them in this open field again. Still wouldn't copulate. They did when we put the tether back on, when we put this jacket back on them. Okay, so we're like, that's really interesting. Let's test this. So we tested it. In the conditioning groups, the males either had 9 trials without a jacket on, or 9 trials with a jacket on. Okay, and this is not a leather-studded jacket, right? There's no fetish wear here. This is just a tethering jacket, so you can like tether them to a spring so they don't go anywhere. So on the final test, they either had no jacket on or they had the jacket on, right? So these guys never had the jacket before. Now they do. These guys had the jacket. Now they don't. Well, you can see what happened here. Condition level changes, which is a behavior that male rats show in a bi-level chamber where they run from level to level. Is a female here? Is a female here? Is a female here? Yeah? Well, guess what? That went down without the jacket on. And the intermission latency tripled, which means they're not getting erections. Or if they are, they're quite delayed. The number of intermissions went up because the number of ejaculations, that's before the first ejaculation, went down. There is a failure to produce arousal. All because they're not wearing their jacket. When in their natural evolutionary biology were they ever wearing jackets? Never. Okay? Which means that their brains, small as they may be, are perfectly capable of showing the same things that our brains do. And what Kraft-Ebing talked about. Okay? But then we said, okay, what if we put the jacket on, oops, go back, sorry. What if we put the jacket on the female? Would they show a conditioned ejaculatory preference for a female wearing a jacket? So does it really have to be odor? No, it doesn't have to be odor. The paired group shows a choice for first ejaculation preference for the jacketed female and more ejaculations with the jacketed female than the unpaired group does. So what does that mean? It means they can tell the difference, yeah? And it also means something very interesting. As a contextual cue, when it's on the individual, it affects arousal. When it's on a partner, it affects partner preference, right? Which probably also is affecting arousal. When it's just on you, it's like, oh, I'm wearing my jacket. Okay, I know what this means, right? And when the jacket's not there, something's missing. What do we call that? A fetish. Rule number 2, opioids are the substrate of pleasure. Not dopamine. Dopamine is not pleasure. Dopamine is attention to cues that are important, whether they're pleasurable or aversive. right? Your dopamine system is going to go up when there's a bear trying to attack you. Your dopamine systems are going to go up when you see someone that you're very interested in and not a bear. How do we know this? Well, I kind of mentioned it before, having to do with naloxone. We can block the rewarding effect of sexual stimulation in both males and females with naloxone, as long as we make that contingent on their first sexual experiences. So they're having their first experiences of no reward. Does that sound a bit familiar from a human context? Maybe. So in males, we either gave them saline injections during the conditioning trials or gave them naloxone injections during the conditioning trials. Okay? Then on the final test, everybody got saline. So what you're doing is you're testing the expectancy of no reward. Right? They get an injection, it's going to be bad again, even though there's no naloxone there on the final test. So now they're showing an expectancy. And sure enough, if we look at the ejaculations, that expectancy not only got rid of the ejaculatory preference, but it also now produced a preference for a novel female. It's like, I know this one doesn't work. I'm going to go after the other one, see if that one works. Okay? And the same thing happened for the jacket, only it was a little bit more robust in terms of going after the novel one. So having saline, you get the ejaculatory preference for the jacketed female, but having naloxone during conditioning, you now have a preference for the unjacketed female. Okay? That's interesting. So what do we know about that system that I told you about? Well, we know that mu opioid receptors exist in every part of these two circuits that we've now brought together by conditioning. We know that whole brain beta endorphin content increases after ejaculations, and we know that the medial preoptic area and the ventral tegmental area are two places where this is really, really important. Opioids here produce the sensation of orgasm. Okay, that feeling, that ecstasy that occurs at the moment of orgasm. That's an opioid effect, right? If you ever want to do heroin, it's going to feel similar, only way more intense. Okay? Whereas here, opioids sensitize dopamine. Okay? So and I'll show you this in a bit, but their activation of their inhibition of dopamine neurons actually turns on an intracellular mechanism that makes dopamine neurons more responsive to cues that have predicted their own reward. Now you may say, wait a minute, that's circular reasoning. It is circular reasoning. It's completely circular, which is kind of what Stendhal was saying, isn't it? Right? So Gonzalo Quintana in my lab then said, well, where? Okay, if I put it in the preoptic area, if I put naloxone in there, or saline during conditioning, and then saline on the final trial, what's going to happen? Well, saline, you got the conditioning. Naloxone, you got exactly what you got in the MPOA from the systemic administration. So the medial preoptic area, critically important for tying those two systems together. 10 minutes, really? Seriously? No, we started late. Okay, anyway. So you get the same thing. When you put it for the jacket, same thing. When we put it in the ventral tegmental area, saline produced the effect, but now it doesn't go the other way, right? You just block the conditioning to the odor, or you block the conditioning to the jacket. So the animals are not going after it because mesolimbic dopamine is not being activated. It's not sensitized. Yeah? Larry Young found the same thing in voles. Yeah? So look at this. Naltrexone, he used a longer acting one. One trial, still got the preference, okay? But after 3 trials of saline, the preference is more. But 3 trials of naltrexone, the preference is now gone for the non-familiar, the strange partner, just as it did in male rats. Right? That's intriguing. And it was a mu receptor effect because CTAP, which is a mu antagonist, blocked the effect, okay, when it was put into the caudate putamen, into the striatum. Not the nucleus accumbens, but it's another region that's part of that mesolimbic dopamine system. Genero did the same study in females. And it's exactly the same. You either give them saline during their conditioning trials or naloxone. On the final test, they get nothing, right? They get saline. And sure enough, what you notice is the naloxone group didn't have the increase in solicitations. They received fewer, they made fewer solicitations, they received fewer intermissions, and they got fewer ejaculations because they're not all that receptive, which you can see here because the number of lordosis 3s has dropped down dramatically. So they're not interested in having sex even though they're fully hormonally primed, okay? Which is crazy. Rule number 3, pleasure sensitizes oxytocin and vasopressin, which act as substrates then for arousal and social bonding. So here we did a study where we had paired or non-paired trained males. We did the open field test, 2 reconditioning trials, and then we gave the almond odor alone on gauze, which again is what we had done in females. Now we're doing it in males. And we look at CFOS within either oxytocin neurons or vasopressin neurons. What you see is greater CFOS when they're receiving the paired male in the paraventricular nucleus, but not the supraoptic. So that's for oxytocin. But it's the other way around for vasopressin, more in the supraoptic and not in the PVN. Okay, so we had a little double dissociation there between oxytocin and vasopressin. What we then did was injected them on their first trial. Okay, so they haven't learned anything yet, but we've either injected them with oxytocin, whoops, go back. We either injected them with oxytocin, vasopressin, or saline on this trial. So what we're trying to do now is the other way around. Instead of saying, okay, well, we know that after 9 conditioning trials, oxytocin neurons are activated here and vasopressin neurons are activated here. If we give it during the first trial, will we potentiate activation on the second trial? Okay? Now, before you run out and get oxytocin nasal spray, okay, which may work, I don't know, nobody's tried it, but before you do that, remember these are rats. So what happened? On the second test, we gave them the open field. And sure enough, oxytocin, but not vasopressin or saline, enhanced conditioned ejaculatory preference. Okay? So maybe it works. We also found that first ejaculations induce oxytocin receptor. So here we're doing autoradiography with iodinated ornithine vasotocin, which binds to oxytocin receptors. And whether they were paired or unpaired, the animals that had one ejaculation showed significant increases in oxytocin receptor in the MPOA, the ventromedial hypothalamus, and the central nucleus of the amygdala. So essentially, conditioning is doing kind of a 1-2 punch. The first punch is, oh, I've experienced an ejaculation. Woohoo! And the second punch is, oh, now more oxytocin is now binding to a greater number of oxytocin receptors. So boom, boom, you're sunk, or you're in love. We also found a similar thing with conditioned mate guarding. So in this FFM test, females compete, and you see normal female competition. I'm getting there. You see normal female competition. What we did here was we paired a female with one male, always in a pacing chamber. So she likes that male. So the male is the boyfriend, the female is the girlfriend, and then we have a competitor female who's introduced into the chamber. Well, I call this an FMF test, where the MF here is the pair, and this is the competitor. Well, the girlfriend does something really interesting, which female voles do, okay, which rats are not supposed to do because they're promiscuous, right? They should just go after the novel one and not really care. But these females care, right? She does this. She hovers and presents to the male. And if the competitor comes over, she gets in between the two of them and blocks him, or blocks her. Well, she actually is probably blocking him too. And if the competitor female runs around and solicits the boyfriend, she goes and mounts the competitor female, which in female rats is well, actually in male rats too, is a dominance thing, okay? And if the competitor female continues to do this, she'll mount her and fight her and actually like basically push her head into the wall, okay? After a number of these kinds of experiences, the competitor female, when she's put in, just stays in the corner. But if the female's not with her boyfriend, then the competitor female doesn't stay in the corner, but she competes. So there's something about the way that she is looking at this behavior that says, okay, she's with her boyfriend, I'm not going anywhere near her because she's going to kill me, okay? But when she's not with her boyfriend, wow, then everything's open, isn't it? Yeah? But that's really interesting. When we presented the boyfriend odor, sure enough, we got, excuse me, we got Pfaus in oxytocin neurons in both the SON and PVN under these circumstances, and vasopressin in the SON again. Okay. We also did the same study we did in males, but now with females under these circumstances. We either gave them oxytocin, vasopressin, or saline during that first trial with the boyfriend. Would that advance the conditioning? Yeah? Well, here's mate guarding after saline. There's no significant difference. Mate guarding after oxytocin. Okay? They solicited more with the paired male. They received more intromissions with from the paired male, and they hovered and presented with the paired male more. So they're sticking by him. They're staying with him, and hence he's engaging in more sexual behavior with her because she's controlling him that way. Yeah? With vasopressin, though, we saw this blocking behavior. Now, vasopressin, think about it. It's going to increase your heart rate, make you more aroused, make you more aware. Where is that female? Whoa, she's not getting anywhere near my boyfriend. Even though they're not really boyfriend and girlfriend yet, which I find really interesting. Then, quantum mechanics in my lab found that if you gave them optimal pacing conditions, you got significantly more vasopressin, or Pfaus within oxytocin neurons in the PVN, in the SON, in the MPOA, and in the ventromedial hypothalamus. Okay? So just the conditioning alone is essentially sensitizing the system. Rule number 4, I only have one more rule. Stimuli associated with pleasure activate mesolimbic and hypothalamic dopamine. Okay, so we did a microdialysis study. The rats were paired versus unpaired, 9 trials, just like we always did, sexual preference test, 2 reconditioning trials. And then we either gave them access to almond odor on the gauze, estrus female odors on the gauze, which everybody likes, and lemon odor, which neither of these males, neither of the groups had ever experienced. When we look at dopamine release with microdialysis, we see in the paired group a huge increase in dopamine when they're presented with the almond odor. It's even greater than when they're presented with receptive female odor. But notice the unpaired group, dopamine goes up with the receptive female odor because it's unconditionally activating their dopamine system, whereas it didn't go up in the unpaired group when presented with the almond odor, and the lemon odor did nothing. Okay, so now you have an epigenetic change in dopamine, a sensitization of dopamine to these cues. Rule number 5. Now remember I told you mu opioid receptor, right, could be, come on, I've only had 40 minutes so far. Okay, it's okay? 5 minutes, okay. So what we did here was we inhibited demethylation, okay? So if we block the epigenetic mechanisms, they act like blockade of reward. What do? We use this LIS-D1A, which is a drug called Horizon. It's an inhibitor of lysine-specific demethylase. Now, you know that genes are typically packed around histones, right? And if you want to have gene expression, you got to unpack them. There's 2 ways to unpack them. You can demethylate them, because when they're methylated, they stay packed, or you can acetylate them. This will unpack them from the histones, right? And open them up to be activated. Now, it just so happens that this lysine-specific demethylase 1A, that particular demethylase is a gene that codes for this flavin-dependent monoamine oxidase, which demethylates mono and dimethylated lysines in oxytocin neurons. So it's very specific to oxytocin. And sure enough, when we gave this, right, it acted to inhibit this hovering and presenting, and to inhibit the blocking behavior, right? Which is very similar to what naloxone did. So if you block reward, you block the activation of the epigenetic mechanisms that sensitize oxytocin and potentially vasopressin. Okay, and this just shows you that too. More Pfaus in the LSD1, in the saline paired relative to the LSD1 paired. And that's true for Pfaus within oxytocin neurons, the SON, PVN, and within AVP neurons, right, in both regions too. Okay? So finally, really, but how? Okay? And this is where we get to some mechanisms that are probably really important. First, I've told you that opioids inhibit but sensitize dopamine neurons. And this has been known from drug addiction studies, it's been known from feeding studies, it's also true of sex, because that mesolimbic dopamine system is responsive to reward-related cues. Okay, here's something you like, you move toward it. Here's something you don't like, oh, you move away from it. Okay? And that happens here in the ventral tegmental area. And it happens because there are mu receptors on the GABA, the inhibitory GABA interneurons that activate dopamine, but there are also mu receptors on the dopamine neurons that deactivate them, okay? But the deactivation process makes them more sensitive the next time a stimulus is there that's associated with the opioid reward. There's also activation in oxytocin receptors. There's the CD38 gene. Very important gene because it's a calcium mobilizer, all right? So the more calcium that the gene, because it's basically it's incorporating this mechanism to release calcium from intracellular stores. The more calcium that's there, the more likely you are to be depolarized. The more likely you are to be depolarized, the more likely you are to spritz out your oxytocin. And animals that have a mutation in CD38, right, have defects in maternal, sexual, and social behaviors. Okay? It's something that people have been looking at in terms of autism. Well, turns out that when you bind a mu opioid agonist, whether it's beta endorphin or whether it's morphine, to mu opioid receptors, you internalize these receptors, and that internalization is part of what activates a MAP kinase signaling pathway. And it turns out that that MAP kinase signaling pathway is absolutely essential for CD38 gene expression. It activates them in oxytocin neurons. So opioids will sensitize oxytocin by activating CD38. Okay? And then you just have a sensitized set of oxytocin neurons. And if you think about this whole pathway, I'm not going to go through this because I don't have time, but really what's happening in oxytocin neurons is the addition of oxytocin in the VTA along with this GABA pathway that is now disinhibiting dopamine. They're focusing that dopamine system on sexual reward-related cues. Okay? And essentially what you have here is like an intracellular Hebbian circuit, okay, where opioids are carrying the reward signal, activating CD38. Dopamine is activating, basically on D1 receptors, is activating a G protein that is now increasing the depolarization of that neuron. But more oxytocin will be released as a result, right, and go to a population of oxytocin receptors that are now already upregulated. So this is also true of this 2x2 oxytocin pathway, where going from the spinal cord, you activate sexual arousal, but going from the pituitary, you activate orgasm. So why is that important? Because it's important because we find oxytocin receptors on the sensory neurons of the clitoris and on the cervix. So what this means is the potential of being with your preferred partner has a reproductive advantage, right? And that reproductive advantage, because you're getting cervical stimulation and upsuck mechanisms that are taking sperm in through the cervix into the uterus. Well, it turns out Mary Erskine in 1985 discovered this in these unilevel chambers. Females that had paced intermissions before an ejaculation, whether it was 5 or 10, were much more likely to get pregnant. And why was that? Because they're getting the sex that they like and not sex that they don't like. And lo and behold, Tamara Cibran-Landarel, when she was in the lab, showed that when they got vibratory stimulation, right, of the clitoris, which also was stimulating the cervix, well, in group 2, which got it, right, group 2 received one clitoral stimulation every 5 seconds, which, remember, produced a partner preference, that also gets them pregnant when they get it before an ejaculation. So orgasm, pleasure, in women, in females, is reproductively salient. Who would have thought that? It's all about ejaculation, right? And the penis. No, it's actually all about the clitoris and the cervix. Right? So, to conclude, think of pleasure and opioids coming from the arcuate nucleus, activating bonding, attention, and arousal in these structures because they're activating oxytocin and dopamine, sensitizing oxytocin and dopamine, potentially also activating vasopressin to activate arousal. These move on up to awareness. For us, attraction, bonding, desire, arousal, and brain areas like the prefrontal cortex and anterior cingulate and sensory cortex that are associated with that. That's the cognitive and emotional awareness of being with or in the vicinity of someone who is hot and someone who you're interested in. Okay? So essentially you have this kind of a system. No me importa si ella es dispensadora de cintas. La amo. Oh, yeah. And that's a fetish. Okay? And with that, I want to say gracias por su atención. Acknowledge all the students who are in my lab, including El Niño here, who now is not a Niño anymore, and the granting agencies. I'll take any questions, maybe, if we have time.